All right, so we talked about discrete random variables yesterday. So in a discrete random variable, you have the number of ways something happens, and you have the probability of that event happening. So here's an example. AP test scores. So the probability of scoring a 1 through 5 are given. So try to answer these questions. Find the probability of scoring a 3, find the probability of scoring less than 3, and find the probability of scoring less than or equals to 3. Now this is important for understanding in when we get to distributions later on, probability distributions like binomial, geometric, and Poisson distributions, being able to calculate these probabilities. So let's take a few minutes to go through that. And this is a Nearpod. I did not make this a draw it slide, so you don't have to write on the Nearpod. I'm hoping that you could just do it in your notes or scratch paper or something like that. Just trying to follow along and understand how to find these probabilities. What's cool about looking at data like this, this is the 2018 AP statistics test, so I got this from the AP website, the results. 27% of students scored a 5. And the AP test, they've been making it a little easier as years have progressed. They started out, it was a really tough test in the beginning. It had some of the lowest scores next to calculus. Probability x equals 3. That's right here. 0.23. That's it. Exactly 3. So we're trying to get used to using the notation and understanding what that means. So x is your variable, less than 3. So we're not including 3. Writing that would be the same thing as probability x is less than or equals to 2. Same thing. So we're going to say probability x equals 1. And sometimes I write x equals, or I'll just write the number. Probability x equals 1 plus probability x equals 2. So just another way to write it. So 1 is 0.15. 2 is 0.2. It's not a 5. Okay. Make a 5. 0.35. 35% of students scored below 3. Okay, why 3? 3 is the important number. 3 is passing. 3 gets you to count it as college credit. Less than or equals to 3, so that's 3 or less. So we're going to add probability of 1 plus 2 plus 3. So I'm going to add 0.15 plus 0.2 plus 0.3. Or plus 3. 0.23. So what is that? 0.58. 58% of students scored a 3 or lower. A little more than half. 4s and 5s, pretty good, pretty substantial there. 3 4s and 5s, find the probability of scoring a 3 or more. So we would add these probabilities together. We're going to take that and use it to find probability of scoring, or find the mean and standard deviation. And then we can answer some probabilities about the distribution. Alright, find the mean and standard deviation for this probability distribution. So I'm going to put the formula down. We could do it on our calculator. So I gave you yesterday, if you weren't here yesterday, we did this on our calculator, but the formula is straight out of the book. Hello? Hey, June. Oh, wow. Okay. It passed smog and everything? Okay. Awesome. Alright, I probably won't be able to get there until this afternoon. Gotta work. Alright. Thanks, man. Alright. So, same price? $4.20? Okay. Alright, sounds good. Alright, bye. So we don't have data on this problem. We can't just find the mean by adding up all the numbers. We can't just add 1, 2, 3, 4, 5 and divide by 5 or something like that, because each number has a probability of that happening. So there's the formula for mean. And we use the symbol mu x for mean. We use the symbol sigma x for standard deviation. So here's formula, sum x p of x. We'll do it on the calculator as well. So we're going to take x value is 1, and its probability is 0.15. We multiply those together. So x, multiply first before you add. That gives you the mean of the distribution. You'd have to say that it looks like it's kind of skewed to the right, because most people scored 3s and 5s. That would have it a little skewed to the right. I don't know, somewhat symmetric, a little skewed right. But we can't just make that assumption based on x, or p of x, we make it on both. So that will give you the mean and standard deviation and apply normal distribution. We could also make a histogram for this set of numbers and probabilities. So usually we only use the probabilities to make the histogram. .19. That's what I got. Yeah, 3.19. All right. So 3.19 is your mean. Standard deviation, the formula for standard deviation, a little more complicated, but it's still doable. Sum of x minus mu times p of x, all underneath the square root sign. Without the square root sign, that's called the variance. So in the book, they call it variance of x and then square root at the end. So I'll just show you the start, the beginning of the formula. Take x. Kiana, can you put on your headphones, please? So we take the first value minus the mean squared times probability plus the second value minus the mean squared times its probability plus the third value squared times the mean, and keep going until you get to 5 and its probability. So I'll put ... there. And usually they'll show the last one. So the last one would be 5 minus the mean. And we subtract and square because standard deviation is always a positive number. It measures the spread of data. So calculating the mean for a discrete probability distribution. If you're given a table like this, you're given x and you're given p of x. How do you find the mean? Use the formula, and the formula is in the book on page, we get the page number. Finding the mean is on page 345. And we went over the roulette question with roulette. Find the mean. It's also called the expected value. The mean is also called expected. Why did I put an E like that? Expected value. How many would you expect? Okay. What score would you expect a randomly selected student to get? 3.19 is the average score. That's pretty good on the AP Statistics exam. A 3 is the average. Well, that's what you would hope. Hope it would be a little bit higher, but that's still a pretty good result, where most AP tests are around 3. The mean is on page 345, standard deviation page 347, and there's examples of those. APGAR scores. Again, the APGAR test is given to babies. It measures all of their senses. So they pinch the baby and make sure the baby cries. and it gets a reaction. That's the sounds kind of sad. Pitching babies, newborns, but it's a measurement of their alertness, an APGAR score. So there's mean and standard deviation for calculating those scores. And then let's do it on the calculator. So we can do all of this on the calculator. Page 348 in your textbook, page 348 has the technology corner, technology tools. So we're going to do it on the calculator. So in X, I would call X list 1. Always call X list 1, and then P of X list 2. Well, in the calculator, this is called the frequency list. The freq list. F-R-E-Q. So I put in 1 through 5 on there. I know it says scores from 0 to 5. I haven't had any students that ever score 0, but I mean, if you don't do anything, you score 0 on problems. So I put into list 1 and list 2. X and P of X. Quit that screen, and I'm going to do on the calculator one variable stats. And if you don't have Stat Wizard, you just put L1, comma L2. You don't have to put L1, L2, that's default. If you just do one variable stats, it'll do your stats for list 1 and list 2. But I always say put L1 and L2 to remind yourself that you did in fact enter data into those lists. So calc, what variable stats? List 1 is L1, freq list is list 2. Calculate. X bar, they call it X bar, 3.19. Standard deviation is what I did not calculate, 1.412. 1.412 is the standard deviation. So when you do that calculation, and we did it yesterday with the car sales on Friday mornings. That was the last problem we did. We did it with the number of pets. How many pets do you own? Finding the mean and standard deviation is really the big point here. And then we can transform it to continuous distribution using normal probabilities. Any questions there? Good with mean and standard deviation? Check your understanding, page 349. Let's see here. Oh yeah, we did that one already. So let's calculate the mean and standard deviation for car sales. So let's try this problem. Construct a probability distribution. So now I'm asking you to build your probability distribution. So you got to find the X and you got to find P of X. X is the amount of money that you win. P of X is the amount of money that you lose. So it's net income on the raffle. And then find the mean and standard deviation. So I'm going to give you a few minutes. Again, this is not a draw it slide, so you can just do it on your paper and your notes. So the goal is to know how much money are you going to win, or in this case, lose. Most gambling games, probably going to lose. If you bet $5 and you lose, that's -5. Okay, so you're going to win $500. But if you spend $5 to win 500, that's $495 net. It's like I tell my dad, he plays lottery scratchers. And he'll spend, they have like $20 lottery scratchers now. It's crazy. And you know, you spend $20, you scratch it off, and you lose, and you throw it away. It's like throwing money away. But if you spend $100 and you make $100, you break even, right? So it's all based on how much you spend. And I tell my dad all the time, it's like, hey, guess what? I won $100. Well, how much did you spend to get $100? $200 is $195 net. And $100 is $95 net. Probability of winning is 1 out of 1,000. So what I would do is, with these big numbers, put list 1 as X, list 2 is P of X. Try to always use list 1 and list 2 so you don't get confused. That's not a negative, it's just 1,000. I just screwed up there. And then probability of losing, how many people lose? 997 looks like. I subtract 3 from 1,000 to get that number. Because there's 3 winners. How many people lose? 997 lost. We don't call people losers nowadays. You're not a loser. You just lost your money. This day and age. Alright, so X is list 1. P of X list 2. And then we would compute. I want to know the mean, mu x. In the calculator, it's called x bar. I mean, that's the only mean that you can find. And then standard deviation, sigma x. And that one's shown in the calculator. Who can tell me what you got for 100,000 bonus points? Anybody like to share? It's going to be a negative number. Probably going to lose money. Expected outcome. So it's negative 4.2 for the mean. But this is in dollars, so what does that tell us? 4.2. I'm going to put a 0 because it's money. And we want to interpret that dollars. Negative $4.20. So that's the meaning of 4.2. Standard deviation is pretty large. I got 17.3 for that. Yeah. And that's in dollars as well. Standard deviation is in dollars. 17.3. Which is $17.30. Pretty large standard deviation. A lot of spread. in that distribution. And that's a lot like the roulette problem. I'm not sure if there's a problem like this in the homework set. And I did modify the homework set. Anybody get a chance to start on a few problems from yesterday? Not yet? Okay. Alright, so that's discrete random variables. Continuous random variables. Let's read example page 351. So this is a review of chapter 2. If you were lost and you disappeared or you didn't make class back when we did chapter 2, really important to know this, bringing back normal distributions, because we're going to talk about normal distributions throughout chapter 7, 8, 9. We're going to use it, so it's good to know. So read through the example page 351. I'm going to give you like 5 minutes to do that. Alright, so this is just using a normal probability distribution, finding the z-scores. And we've done a lot with z-score, comparing z-scores. The lower bound is 68, the upper bound is 70. Find the probability you're between 68 and 70. That's 5'10" and or 5'8" and 5'10". Find the probability a female is between 5'8" and 5'10". How many females, or what's the probability of that? That's a pretty tall female, right? If the average height is 5'4", 5'8" and 5'10". That's pretty tall. Okay, so not very many, not very large probability. So we expect a small proportion. We could use normal CDF to do this calculation. If you do normal CDF, put your lower bound 68, your upper bound 70, your mean is 64, and your standard deviation is 2.7. You can come up with that probability, which is 0.05. About 5% of females or young women are between 68 and 70 inches tall. This is really useful for what we're going to get to in 6.2 because we're going to compare two random variables. So we'll have two probability distributions, and we have to compare those, transform variables, stuff like that. So, homework. Any homework questions? Again, I modified the homework so you can have less problems. I think I did 2 through 16 or something like that, or 2 through 18. I think the life insurance one, it's problem 14 and 18, life insurance. That's probably going to be your toughest problem here because you got to create a normal probability, and the probabilities are really small. Probabilities are used to calculate how much money you spend monthly on life insurance. Okay, so the older you are, the more risky activities you partake in, the higher your monthly insurance is going to be. Any homework questions? Do you want me to go over one of them? Just shout it out. Just be like, hey, number 6, or something like that. All right. I guess we're good. I'm just going to give you time. You know what? I'll stay on Zoom. I'm going to end the